A very good morning, my dear students. Welcome back. Let's continue the fourth dimensional analysis application. What was the fourth dimensional analysis application? Of course, it is the last dimensional analysis and its application. It is designing our own system of units. Okay. Let's take few physical quantities and you can consider it is a quick recap about the physical quantities and its dimensions. Let's consider the acceleration or acceleration due to gravity and whose dimensions are Lt minus 2. And you can take a force dimensions are mlt minus 2 because mass into acceleration. So you can take the dimensions of work or energy. So it will be work, for example, force into displacement. So that I can write ml square t minus 2. Let's take pressure. Pressure is equal to force per unit area. We have force mlt minus 2, area is L square. So ml minus 1, t minus 2. In that way pressure we get. Let's take for example a surface tension. So these are the quantities I had introduced previously. Surface tension. Surface tension is force per unit length. Force we have mlt minus 2 by L. So mt minus 2. Let's take the angular momentum for example. Linear momentum we know. Angular momentum is what? M into V into R. So that is V is Lt minus 1. R is L. So ml square t minus 1. So this is the angular momentum. Alright. Torque. Let's see one more. Torque is equal to force into perpendicular distance. Whatever it may be, it is distance. So that is why I wrote force into distance. Force is L t minus 2 into distance L square ml square t minus 2. Alright. So like this, so many physical quantities and their dimensional formulas we have learned so far. Why we have just had a quick recap? Because any physical quantity we have considered so far is represented in terms of mass, length and time. Any physical quantity you take. So mass, so don't consider that, see, don't think that there is no mass. The mass is there, m raised to 0. To represent the quantity acceleration due to gravity, the mass is raised to the power 0. That's called its dimension. Okay. To represent the quantity called angular momentum, mass is raised to the power 1, length L is raised to the power 2, t is raised to the power minus 1. Those are called dimensions. Alright. Every physical quantity we have considered so far represented in terms of mass, length, time, and of course those mass, length, times are a fundamental physical quantities and they have given in a SI system of units. Alright. The fundamental system of units is SI system of units. In that SI system of units, mass, length, time is mentioned. Clear? Nothing new. Just what we have discussed already. Now imagine, any physical quantity I am representing in terms of mass, length, time. After solving so many questions by this time, imagine, just assume that we have felt bored in writing each and every physical quantity in terms of mass, length, time. Just imagine for time being. For small and short time duration, imagine that we have got bored by writing any physical quantity in these three physical quantities, in these three mass, length and time fundamental quantities. What I am going to do is, I I am considering that. See, I am considering that carefully. See, I am considering that pressure denoted with the symbol P, a velocity denoted with the symbol V, and time denoted with the symbol T are fundamental quantities, right? So what I have considered, so these are my fundamental quantities. I considered these are my fundamental quantities. So how the force can be, force is a physical quantity represented with the term F. How this force can be expressed in my fundamental physical quantities? Generally, the force is represented in the dimensional formula mLT minus 2. When mass, length, time are fundamental quantities. But here, what are my fundamental quantities now? My fundamental quantities are pressure, velocity, and time. So this is the question. I hope you understand the question. What is the question? If I choose my fundamental physical quantities are pressure, velocity, and time, how the force can be represented in terms of these fundamental quantities? Alright. So the basic step you should solve like the previous case, previous condition or previous application is what? Deducing the relation among the physical quantities. Yes or no? So same condition. So the step you should not forget. So the dimensions of the force is equal to, see, I have the force dimensions mLT minus 2. So this is called m1 L1 T minus 2, right? So the same force dimensions I can write in this way, right? m1 L1 T minus 2. But in the places of m, in place of L, in place of T, so this will come. So pressure P, velocity V, and time T, alright? But the powers, dimensions, we don't know. Here, force, mass into acceleration formula we have given. We have done. So then you got this rise, m raised to 1, L raised to 1, T raised to minus 2. But here we are not yet done. So that is why let me keep P raised to A, V raised to B, and T raised to C. And like how we have done in the last application, the same way let's move on. Force dimensions. What is the force dimension? M, L, T minus 2. That is M1, L1. That is force dimension, which is equal to here. What I can write? Pressure dimension. Pressure dimension, just now we have M, L minus 1, T minus 2. M, L minus 1, T minus 2 raised to A, that is pressure dimension. And velocity dimensions, L, T minus 1 all raised to B. So then time dimensions, T raised to C. Okay. M raised to 1, L raised to 1, T raised to minus 2 will be equal to here, M raised to A, only one, M raised to A. L, so many L's are there because L is here, L is here. So I can write L raised to, this is minus 1 into A, it is minus A. L raised to B, L raised to minus A into L raised to B, right? See, again I am writing here, L raised to minus A into L raised to B. What I can write? L raised to minus A plus B. Yes or no? Tell me. Right? So this is in the form of x to the power n into x to the power m. So this is what I can write, x to the power n plus n. This is the formula, basic mathematics. And thus there is no advanced mathematics I have drawn here. I have not drawn here. Okay. So L raised to minus A into L raised to B. So L raised to minus A plus B. Then T. Here one T is there, here T is there, here T is there. So here T raised to minus 2A, here T raised to minus B, right? Minus B, and it is T raised to C, so that is plus C. Okay. This we have done in the last class. So now it is just about the equity. Both sides equate. Here m raised to 1, here m raised to a. So I can write a is equal to 1. It's done. A is equal to 1. Now, minus a plus b. Minus a plus b is equal to 1. So from here, I can write b is equal to carefully see, b is equal to 1. This minus a comes to the other side, that will be plus a. So what I can write, b is equal to 1 plus 1, it is 2. So a is 1, b is 2. Okay. The last one, what is the last one? So minus 2 is equal to minus 2a minus b plus c. Minus 2 is equal to minus 2a, a is 1. Okay, minus 2 into 1, minus 1. Minus b is 2, okay, 2 plus c. So this is minus 2 is equal to minus 4 plus c. Okay, so this minus 4 you can take to the other side, it will be plus 4. 4 minus 2 is equal to c, and c is equal to 2. Okay. Why we are doing this a, b, c finding? Tell me. Just to identify the dimensions. So finally, this a, b, c values you substitute here. A, b, c values you substitute by taking from here. Okay. A, b, c values you substitute here. So from these a, b, c values, if you substitute here at the final, the force can be written in terms of pressure, velocity and time just by raising the pressure dimensions to a is 1, P1, V to the power B, B is 2 and C is also 2. Okay, to represent the force, pressure is raised to the power 1, velocity is raised to the power 2, time is raised to the power 2. So this is how you can write the force in terms of pressure, velocity and time when you choose your own system of units. In your own system of units, you consider the fundamental quantities are pressure, velocity and time. My dear students, I hope you understand the topic and just get ready for the class work. And before the assignment, the class work, get ready for the class work. Alright. Before moving to the classwork, let me tell you once again. Simple. Any physical quantity you take, let us take an example of angular momentum. Angular momentum, dimensional formula is written already in terms of mass, length, time. Why? Because in our SI system of units, mass, length and time are considered as fundamental quantities. Clear? Instead of mass, length, time, for example, if you consider your own fundamental quantities like pressure, velocity and time, you can write the angular momentum also in terms of pressure, volume and time. So pressure, velocity and time. Okay. Clear? Now your class work is, let's take the same. Write this angular momentum. Write this angular momentum in terms of pressure, same, velocity and time. Let's see how you do that. Angular velocity formula I have given already. Mass into velocity into r. Mass, velocity, LT minus 1. R is the length, ml square t minus 1. Angular momentum dimensional formula you know, right? How you will be doing it. So angular momentum, imagine it is denoted with the symbol A, which is equal to pressure, P to the power A, velocity to the power B and time to the power C. Find A, B, C's and identify the correct answer. So this is your class work. This is your what? Class work. Right. Whenever you have a lot of time with you, class work or homework you need to make yourself whenever you have a time. And you agree, and I know that you have a lot of time for practice. You write work in terms of pressure, velocity and time. You write dimensions of the torque in terms of pressure, velocity and time. So that's called your own creation of the work. Alright. Let's move into the next topic. Let's see the two important things we are going to discuss in this slide. Number one is a dimensionless quantities. And limitations of dimensional analysis. Okay, these are the two things we are going to discuss now. First, dimensionless quantities. Let us see. Some already we know the angles, ratios will not have the dimensional formula, that we know already. But still, some more things to be understand in dimensionless quantities. What do we know already? Angles will not have any dimensions, and a ratio of a similar quantities also will not have any dimensions. Alright, like relative density and refractive index, they don't have dimensions. And the pure numbers will not have any dimension, like 1, 2, 3, 4, including pi. Pi is having a value 3.14, it will not have a dimension. The numbers will not have dimensions. And most important thing I'd like to tell you is trigonometric functions. Exponential functions, logarithmic functions will not have any dimensions. Look at here. Logarithmic functions, trigonometric functions, exponential functions will not have any dimensions. What exactly meant by them, I'm going to tell you. Listen to me carefully. So be careful, my dear students here. Trigonometric functions, let us take. For example, I have written sine theta. This is a trigonometric function. Trigonometric function will not have dimensions. First thing I can write this complete, it's m0, l0, t0. The complete sine function or this trigonometric function is not having any dimensions. Clear? Now, within this there is an angle here. Carefully, so there is an angle. The angle also will not have any dimensions. M0, L0, T0. Okay. Sometimes they'll give like this. Sine of, carefully, sine of, look at here, sine omega t. They'll give like that. Forget about it whether you know about omega or not. For your better understanding, I am writing this omega is equal to angular velocity. I hope you could recollect this. V is equal to r omega. Linear velocity is equal to r, radius of the circular path, into angular velocity. From here, omega is equal to V by r. Okay, actually it's not required, but still I would like to recollect or recap what is omega exactly. That is omega. Sometimes you get a trigonometric function like this, sine omega into t, whatever it may be. The complete function is called trigonometric function. It will not have dimensions m0, l0, t0. That's it. And this is called theta. Yes or no? Sine of something is sine theta only. Okay, sine of something is sine theta. So this omega into t also will not have any dimensions. also will not have any dimensions. Clear? This omega may be having some dimensions, the t may be having some dimensions, but whatever it is there written as an angle, it will not have dimensions. Clear? We'll take an example and I'll discuss with you in detail. For time being, try to understand one by one. So this much detail, whatever I strongly tell you, whatever the book you take, it will not be explained in this way. Now, let's take one more. See, slowly we are just increasing the level here. I'll write sine omega t plus x. Anything inside it may be anything. X is a physical quantity, t is a physical quantity, omega is also a physical quantity. Carefully see, my dear students, here, carefully see. So the complete trigonometric function will not have any dimensions, m0, l0, t0, and this angle will not have any dimensions. Right? Angle will not have any dimensions. So this part will not have any dimensions. So but there is an addition is going on between two physical quantities. Whenever there is an addition is going on, according to the principle of homogeneity, this quantity dimensions must be equal to this quantity dimensions, but this complete sum will not be having any dimensions, right? That is dimensionless. So it automatically tells your omega t will not be having any dimensions and your x value also will not be having any dimensions. That's it. If you really understand this part, and lot of the numericals you can solve. Again I'm telling my dear students. So this is all right? So theta will not have any dimensions, complete trigonometric function will not have any dimensions. In the same way, here also, this theta, here theta is omega into t, sine of something, that something will be theta. Right? So this is not having any dimensions, m0, l0, t0, and the complete sine function, it is a trigonometric function, is not having any dimensions. But when you write omega into t is not having any dimensions, so this omega may be having dimension and this t may be having dimensions. Okay? Alright? Look at here. And next, in the bracket, in place of theta, I have added one more physical quantity. Right? So sine of omega t plus xc. Do not get confused about the equations. Actually, these equations you will get in the last chapter of your first PUC. But what we can do now? This is the chapter called Units and Measurements. Units and Measurements chapter will not have any specific units. In this chapter, there is a collection of so many physical quantities and their units belongs to your +1 and +2 topics, and that's what I'm telling you from the day one. Don't get afraid, don't be confused. Right? Try to understand. Sine omega t plus x. So this omega t plus x will not be having any dimensions. That means these two need to have the same dimensions because there is an addition is going on. According to the dimensions, wherever there is an addition or subtraction is going on, they must have the same dimensions. That's called principle of homogeneity. According to that, omega t will have dimensions equal to x. Will have dimensions m0, l0, t0 because this complete part will not be having any dimensions. Okay? Clear? So let us solve a simple basic numerical here. Right? Simple basic numerical. For example, the question is given like that. Y is equal to a sine omega t. Alright? So, y is the displacement of the particle. What is that? A displacement of the particle. And A is maximum displacement of the particle. So whatever it may be, both are lengths only given. Yes or no? Length only. This is a length and this is also a length. Okay. This is a length and this is also a length given. Now, the question is, t is time. They mentioned that t is time. This is y is displacement, a is maximum displacement, t is time. So the question is, find the dimensional formula of omega. What is omega? They have not mentioned. That may be a constant or maybe a physical quantity with dimensions. Okay. Find the dimensional formula of omega. So simple. Whenever you see such kind of questions, immediately you should recollect that trigonometric functions will not have any dimensions. That means the complete trigonometric function is not having dimensions. That indicates sine of something means this is theta. This will not have any dimensions. I can write omega into t will not be having any dimensions m0, L0, t0. So this omega dimensions we need to find out into t. T dimensions are time dimensions. Okay, because t is time dimension. So which is equal to m0, L0, t0. So when this t goes to the denominator, so omega dimensions will be, this is 1 divided by time dimensions are t, and that I can write t minus 1. Alright. So the dimensions of omega is what? Dimensions of omega is what here? It's time. Okay. Clear? My dear students. Sometimes the question can also be asked in this way. What is the dimensions of y? Right? So, dimensions of y and a, let's see, it's already given. Dimensions of y will be L. Dimensions of a also maximum displacement. So, whatever it may be, this is displacement. So, that dimensions also will be L. But according to the dimensional analysis, you need to do that. Or according to the dimensions concept, you need to do that and see. Y, dimensions of y, L is equal to dimensions of a, L, dimensions of this, m0, L0, t0, and this equation is that this is 1, right? This is 1. The complete value will be 1 here. So left hand side and right hand side are having the same dimensions. And you can say this is the equation dimensionally correct. Okay. Clear? This is about trigonometric functions or dimensionless quantities. In the same way, exponential functions also will not be having any dimensions. Exponential functions, when I say e power x is an exponential function. See, what exactly meant by the exponential functions, what is meant by the logarithmic functions, you will understand in the mathematics. In your first PUC and second PUC mathematics, you will understand there. But for time being, what is an exponential function? E raised to x. That x may be a physical quantity, right? So, e raised to x is an exponential function. So, the complete exponential functions will have the dimensionless m0, L0, t0. In the same way, whatever is the power, so that will also have no dimensions, m0, L0, t0. Alright? Alright, my dear students? Clear? Question is asked in this way. Question is asked in this way. Carefully see. Carefully look at the question. There is a physical quantity. There is a physical quantity P is equal to P naught into e to the power minus alpha t square. This is the physical quantity P. Its equation is written in this way. You know what is P naught? P naught is initial value of quantity. Same physical quantity only. For example, if you take it is mass. This is mass. And this is initial value of mass. Both are same physical quantities only. And t is time. The question is, find the dimensional formula of alpha. Simple. Find the dimensional formula of alpha. Alright. So what I have told you, when you find an exponential function or trigonometric function or logarithmic function, immediately write down. So this will not have any dimensions. When this is not having dimensions, and this alpha t square also will not have any dimensions. See, I told you. When e power x is not having dimensions, this x also will not have dimensions. So I can say that alpha into t square will not be having any dimensions, m0, l0, t0, and these dimensions of alpha will be equal to m0, l0, t0 divided by t square, so that t minus 2. Alright, this is the dimensions of alpha. Clear? I hope you understand the topic. So your alpha value will be t raised to minus 2. Same way logarithmic functions also. Okay? So this is how the numericals and the concepts will be discussed. I hope you got the point. Now let's solve one or two examples and move on to limitations of dimensional analysis topic. Look at the question here, example question. Given y is equal to a cos of this expression. So further reading, without further reading, you should understand that the complete trigonometric function, the cos of something, will not have any dimensional formula. When this trigonometric function is not having any dimensional formula, and this part will not have a dimensional formula, that means whatever is written in this place will not have any dimensional formula. Alright? What is that? A t by p dimensions will be equal to, because there is a subtraction is going on, qx dimensions will be equal to m0, l0, t0, because there won't be any dimensions for this subtraction. For this subtraction, no dimensions. As you are subtracting, so this dimensional formula must be equal to this dimensional formula. Okay. So let's consider these two. So then you get t by p is equal to m0, l0, t0, and this is 1, right? The complete this value will be 1, and that I can write it as dimensions of the t value is equal to dimensions of p. Okay? And where t is time, so they have given it is time, and x is distance. X is distance, x comes here, x is distance. So the dimensions of p is equal to dimensions of t. That means units of p is equal to units of t. Keep it aside. Let's take these two. Dimensions of the q into dimensions of x is equal to m0, l0, t0. And this dimensions of the q is equal to, this is 1 by dimensions of x. Right? So this I can say that dimensions of x minus 1. Okay. Dimensions of the q is not equal to the dimensions of x, because it is 1 by dimensions of x. If x is length, so dimensions of the q will be L minus 1. Okay, so for example, dimensions of the q, if you want to write, is 1 by L, because x is given as distance, and that will be L minus 1. Read the question once again. There is a trigonometric function is given, y is equal to a cos of something. The something will not have any dimensions, but there is a subtraction. So this value will have similar dimensions of this, will have the dimensionless. When I take these two equations, I got dimensions of p is equal to dimensions of t. When I take these two equations, I have not got the dimensions of q and x are equal. No, I have not got that. I have got the dimensions of q and x are different. See. Let us see options. Dimensions of x and q are same. Dimensions of x and q are same. Is it correct? Dimensions of q is equal to 1 by dimensions of x. This is correct. This is wrong. Dimensions of x is same as p. Can I say like that? No. Dimensions of p is same to as t dimensions. This is also wrong. Dimensions of t is equal to dimensions of q. See, dimensions of q is equal to dimensions of 1 by x. No. So then this is the correct answer. Dimensions of the units of t is same as p. See, units of t is same as p. If it is time, units of time is second, and definitely as the dimensions are same and the units also will be same. Okay, but here 1 by x, that is 1 by meter, so that is meter inverse. Okay, clear? So dimensions of q, or units of q is this one. Units of q is what? Meter inverse. Units of q is not just meter, it is meter inverse. Units of q is different and units of x is different. Units of x is meter. See, units of x is meter, but we have got units of q is meter inverse. So that is why fourth option is correct. This way questions will be asked. Now let's come to the last topic of the dimensional analysis, a complete dimensions topic. Limitations of a dimensional analysis. Limitations. What are the limitations? Listen. So important for your first PU theory exam. In theoretical exam, this part is important. Let me tell you the first thing. By using principle of homogeneity, left hand side is equal to right hand side part. I hope you could understand. So that is what we say, the principle of homogeneity. By using this principle of homogeneity, imagine that we have found one physical quantity and its dimensions. Right? Find the dimensions of x, unknown. We have found, we got m l square t minus 2. Listen to me carefully. According to principle of homogeneity, we have found one dimensional formula of an unknown quantity. This is what? That dimensional formula. M L square T minus 2. Okay. Now the interesting thing I'll tell you. Unknown quantity dimensions we have got. What is that quantity? If I ask, what you will tell? Some students will tell me it's work. Some students will tell me it is energy. Some students will tell me it's potential energy. Some students will tell me it's a torque. Unknown quantity, dimensions we have got. But what is that quantity? Because the topic we had discussed earlier was quantities with the same dimensions. Here, the usefulness of that is here. If you understand the topic called quantities with same dimensions, and you will understand the limitation. There is a limitation for principle. There is a limitation for dimensional analysis. We cannot use this dimensional analysis for everything. There are some limitations. This. And the second limitation was like this. Let's see the second limitation. By deducing the relation among the physical quantities, we have got some equation. T is equal to some constant k into square root L by G. Right? What is the value of the k? That constant value, right? Value of the constant is how much? We cannot tell by using dimensional analysis. So we have got one more. F is equal to m square by r into some constant. Do you remember? In deducing the relation among physical quantities, we have got this. What is this constant value? We cannot find by using dimensional analysis. The constant, if you want to find, you need to go for experimentation. What is that? experimentation. About this experimentation, we will be discussing in the next classes. So dimensional analysis cannot give you the value of this k constant in your relationship. And trigonometric functions, exponential functions, logarithmic functions cannot be derived by using this dimensional analysis. Okay, that is one more limitation. You cannot derive the equations. You can derive the equations only in this way. And only if the physical quantities are related according to the division or multiplication, only the dimensional analysis can give you the relationship. For example, by using the dimensional analysis, I cannot derive the equation called half at square plus ut. Is it possible to derive this equation by using dimensional analysis? Especially the third application called deducing the relation among physical quantities in this way? No, because there is a multiplier, there is addition is involved here. Okay, it's impossible. You cannot do this. You cannot derive v is equal to u plus at by using dimensional analysis. Wrong. Okay, these are the limitations of dimensional analysis. Get ready for your assignment of 10 questions. All the very best.